Hello, welcome to Mr. CFD. In this video, you will learn how to generate the geometry of the domain around the base geometry, the geometry of the car, and then mesh it in ANSYS Fluent software. Let's start generating the geometry. First, open a workbench window. When the workbench window is opened like this, from the toolbox, component system, choose geometry and drag it to the blank window of workbench. Then right click on it and select space claim as the software to generate your geometry. Click on it. When the space claim is open like this, first we should read the base geometry. To do that, click on File, then Open, and we can choose the file of geometry, which is in IGS format. So yeah, we have the base geometry here. Open it. So this is the base geometry of the car, and now we want to create a domain around it. If you click on structure, you can see, yeah, this is a solid, and now it's time to make the domain around it to simulate the airflow in ANSYS Fluent software. First of all, choose plane in create section of toolbar, and click on the actual base coordinate. As you see, there are 3 planes that we may need them to create the domain around the car. First of all, back to select, and I want to select this plane, and then using move command, I want to move it about 5 meters or 5,000 millimeters. It's because we want to have the domain in which the lens actually in front of the car is 5 meters, but the lens actually in the back of the car is much bigger, around 10 meters. That I will explain why is that. Okay, so back to select and click on this plane and make a sketch on it. Look at it in this view. And now in this view, first I choose line command and draw a line from this point about 250 millimeters. Yes. Then from the end of the line that we have created, I want to create a rectangle with 5,000 millimeters and 10 meters. 5 meters. And repeat this one in the left side by mirror command. Choose this as the mirror plane and repeat these edges. So yeah, now we have this rectangle like this, and choosing trim command, remove this edge, and now we have the surface. If you back to 3D mode, the surface is created like this, and if you go to structure, you can hide the created planes. Okay, now we have the surface, but before that we can remove this edge too. Okay, and click on the surface, and then choose pull command, right click on it, then choose no merge. This way, when you extrude the surface, the solid created around the car is separated from the car solid. So now I want to extrude the surface in X direction with 20 meters. Yes, back to structured and click on it. Try to have transparent view. Yes. So this is the domain around the car. Speaking of the dimensions of the domain around the car, actually the large domain ensures that the airflow around the car can fully develop without being constrained by the boundaries. This is crucial for accurately capturing flow characteristics, especially at high speed, like this problem that has 77 meters per second. And I can say that by having a domain much larger than the car itself, the influence of the domain boundaries on the flow around the vehicle is minimized. Actually, this helps in obtaining more accurate results, particularly for drag force calculations. And the length of the domain, 20 meters actually, which includes 10 meters, approximately 10 meters in the back of the car, allows for proper simulation of the wake region behind the car. This is important for studying flow separation and turbulence in the rear of the vehicle. But the last step to complete the geometry so that we can transfer it to ANSYS mission is that we should separate the solid of the car. Actually, not separate, we should remove it from the whole domain around it. To do that, we can choose combine command and choose the big domain around it. Then by using this cutter, click on the car solid. So yeah, as you see, this option is activated, which we can remove the car solid by using that. So click on this one, yeah, and also again this one, which is about the car. And if you right click on it and delete, yes, so now there is no car solid anymore, and we have only one solid that the car has been removed from the domain. Actually, it's because we want to simulate airflow behavior around the car, and we don't need the solid domain of the car actually. Okay, so yeah, it's done, and now we can close space claim and then go for meshing. After closing the space column, you can see green check mark is activated for geometry, and then we can choose mesh from this toolbar and drag it to the workbench window. Then click on geometry and draw it to the box of B. So yeah, here we have the geometry, and now we can double click on mesh. So ANSYS meshing software will be opened. So yeah, the geometry is transferred to ANSYS meshing software, and we have the geometry here. Yes, the geometry. And first of all, you should make sure that if you click on mesh, in details of mesh, the physics preference should be on CFD. Okay, and first of all, we create meshing by actually this element size to check if the geometry would be meshed or not. So right click on mesh and generate mesh. So as a primary meshing, the geometry is meshed, and we can check. And if you want to see how the mesh is inside the domain, actually meshing on the car walls, yeah, this is like this. And we can check how many cells are created from this section, statistics expanded. So yeah, now we have about 1 million cells. Hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.